Hi, VMman75 here. In this video, we're just going to look at some of the things that Noded is capable of by opening up some scenes that have already been created. And then later on, I'll just talk about in other videos how we can connect up nodes to do some of our own stuff. But let's just go ahead and see what Noded can do. So let's have a look at some of the things. So one thing that I've already showed you is L systems. So let's have a look at another L system. So this is kind of more of a shaded version, and we can go in and adjust many of the attributes. I could come in here and change the angle of that if I wanted to, and you can see that. So it's got some L system capability. Let's go and have a look at another example. Um, Let's have a look at this procedural gears. So this is just a system where the gears are being created using Boolean unions. So I can play that. It's also got some animation on there. I can go to this, for example, this int, which is generating how many teeth each gear has. I might want to adjust that. Keep it plain as I'm doing it. And you can see that I can change the amount of gears and it will update procedurally. Um, and all of this started off as a circle, and then adding a rectangle, and then like I said, just using a Boolean operation, um, and then using some transform nodes and so on and so forth to position things and get all the rotations to work negatively for one gear so that it rotates in the opposite direction and so forth. So we'll just stop that. Have a look at some other examples. Just a real basic omp scene, um, where in this case I'm using a Luma key um, to show you that instead. So if I was to show you this image, just drag that in here. That's the image, and then a Luma key was used to combine those together. And so we have like your classic grade nodes and our merge operation node and so forth. Or I can change the style that I want to have the nodes or the images, the operation, how they blend together. So again, just some basic compositing stuff. Um, in this case, there's a bit of a reaction diffusion model here using some nodes. So we've got our refraction diffusion grid, and then we've got our step node. So just some fun nodes to put together to create some nice animated shapes. We can obviously change the values to on the step node to generate some interesting shapes. Stop that. Speaking of simulation, we've got a particle system as well. So I'll go and find here this thing called fire dynamics, which is kind of interesting. It's just basically a particle system, and I've instanced a star to the particle system. You know, with a bit of wind and a gravity force, turbulence. The turbulence isn't being used at the moment, but it's not plugged in. But you can see, go at a basic particle system. I'll show you another example of a particle system, which is a candle flame. So this one's using streak to draw the particles instead. And so we have ramps that are driving the color and the opacity and so on and so forth, and some fields, all the rest of it. Again, it's not meant to be, or it's not going to be anything like Houdini's particle system or Maya's particle system, but it's all right to do some simple stuff. We can have a look at some basic animation. So let's have a look at the I'm looking for the keyframe example. There we go. So this is just a very simple animated 2D ball. You can see the keyframe sequence in action here. So on the translate Y, so I've got a bit of squash and stretch in here, which is kind of cool. I've muted this path sampler node, which is, I'll mute that. It's just a nice way of visualizing the path that was animated. And if I wanted to, I could just select the transform, and the transform will bring up a manipulator. So if I wanted to make go turn on auto key, might want to make a change on that, and maybe just bring that up. And so that will automatically key that. And just update that. Yeah, so the basic animation. Let's have a look at some other examples. We'll look at this game of life simulation. So this is just another few nodes to simulate some game of life. We can change the rules here. If we want, change the colors. We can also do some, if you've got your API key, you can install that. The API key is required for the AI builder, where we get AI to build, will attempt to build some nodes for us. But if we want to use AI with some of the AI nodes, we need to make sure that we have your own API key, which I'll explain how to do in another video. So I'm just going to open up this AI chat example. And in this example, you can see I've got the chat logger docked over here. And I've got some string nodes. I've got this persona, which is basically a way that I can give the AI agent a name. So this is Albert Einstein. Basically, he's a theoretical physicist, and the rules is always answer questions as if you are Albert Einstein. And we can concatenate the persona with the user prompt, and then the Gemini worker is just here. That's the node that does all the work. But anyway, so if I was to come over to the prompt node, I'm going to clear that, and I'm just going to type in hello. And basically I can have a conversation with an AI that thinks it's Albert Einstein. And so you can see these are just some of the AI nodes. And you can do lots of various interesting things with some of the AI nodes, make little agents and stuff like that. Let's have a look at another example. So also have some other ways to visualize some things, like a Julia set. So we can simulate Julia sets. Also things like other similar Mandelbrot sets. Of course, we can change color values and things like that if we really want. We can do something a bit strange there. We can change the resolution, a whole bunch of stuff like that. Let's have a look. We can also look at an animated Julia set. So it's all procedurally animated. There's no keyframes in this particular one. It's just being driven by the frame node. Um, that's kind of cool. This is something that I've been working on. It's just kind of interesting. It's not very I would say accurate, but it's like a 2D von Neumann probe simulation. So a little node that kind of simulates way it works is we have Sol, and these are just imagine they're kind of some galaxies, and we shoot out a certain amount of probes, and basically the probes will shoot out. If they hit a star, they will split, draw a line, and just continue to explore the galaxy and claim territory for us humans. Just a bit of a fun thing. And you can see at the top here how many systems that was because I just plugged in some the data from the Evolver node into some text nodes, and it would just draw out. They kind of look like constellation lines, but essentially that is just a little von Neumann probe simulation um, that you have access to. So that kind of explains a lot of the things that Nodit can do. Like I said, it's not meant to replace any particular tool. It's more of a hobbyist, fun tool where you can do some interesting things. Yeah, so I might just stop that. I might just do one little example before we move on. So let's just say I wanted to shatter something. So I might start off with a rectangle. Now I can't see my rectangle yet because I need to draw it. So um, typically you need a draw node. There's lots of draw nodes. In this case, I might use a draw poly, and I can plug the output into here. Then I can see my polygon rectangle. Um, Generally, when you click things, the draw tool will be deselected. So you want to pin. Only draw tools can be pinned. Like if I click the rectangle, I can't. It says display nothing. So if I click that, it says I can pin it, and that means I can work away and still see my rectangle. But maybe what I want to do is instead of plugging it into a rectangle, I might want to use a Voronoi shatter. So then I can maybe just replace that. And also, yeah, if you've already got an input, if you just drag over it, it will replace it. So you can see now that we've got this shattering occurring. You can also press F inside of the visualizer and that will frame what's inside of it. And one thing I didn't mention is if you hold down, if you turn on the grid snapping, your nodes will snap. You can also press L to lay them out, but it's a bit experimental at this point. I need to do a bit more work on that to make that work a bit better. But essentially now my nodes are snapping, and the hotkey for that is Control X to turn that off, and X will toggle the grid on and off. So yeah, I can basically come in here, and on my shader here, you can see I've got some inputs. So maybe my number of points, I might make an integer. I'll maybe set that to 30. And that's turned green because I left auto key on. I might just remove that. There we go. In my demonstration, I left auto key on. So that little key just kind of represents if a node can be keyframed to start with. But when it turns green, it means that it's been used in the keyframe sequencer. So I'm going to maybe make that 30, and you can see that's going to change the points and how it cracks. And I can make, let's say, a float node, and maybe make this 0.2, and I can drag this into the thickness to make that a bit thinner. And I can turn off the manipulator, sorry, not the manipulator, the origin. Makes it a bit easier. I might just turn the grid off as well, so it's nice. And so if I really wanted to, maybe I wanted to shade this a little bit, so I can just create a color node, like let's say color constant. I'll make that, I don't know, pink or something, and I can throw that into the fill color, and I can control the color of the line as well, the stroke color, but that's kind of a bit boring. So maybe instead what I'll do is I'll delete that and I'll create a ramp. And I can plug the ramp directly in here, but it's not really going to do much because it's just using one of the stops. Got two stops, doesn't understand, but because this is in a list, each shape is in a list, what I can do is I can use another node called map to gradient, map points to gradient. And this is wanting a list of the points that are coming from the shader. And then I can throw the output into the color list. And now I can just plug that into the fill color. And now you can see that I can get something a little bit more interesting. And I can come in here, you can double click on here. I can add in, say, a bit of a different color scheme here. Okay, so I can just play with that, play with those values to get something out of there. Okay, so that's basically just a really simple example of how we could do something. We've noted it, and if I wanted to, I could also create a transform node. And transform nodes are special because they allow us to manipulate things inside of the visualizer. I can plug this output into the input of the rectangle, and so now I can move this around. And on the grid, you can see it's actually moving, and I could rotate it. See that it's kind of swimming through that because the transform is occurring before the baronial shatter. So I would have to probably collect, add the transform later if I wanted it to move. But anyway, you can see I can do that, and I can scale it. This handle here that is hollow means I can scale the node. Basically, the X and Y are independent, whereas if I was to use this one here, it keeps it locked. And if I just double click the transform in, you can see all the modifications occurring in real time. And this node can be keyframed. So we're just going to leave that there for now, and I'll see you in the next video.